Hello everyone, welcome to the Touchdesigner free tutorial. In this lesson, we'll cover using feedback and displace, including top of slope. What you see in the demo is basically a 2D cloud-like effect created by combining noise and displace with feedback. On top of that, we layer a field of tiny stars made with the particle GPU. In this lesson, we'll build this effect together. First, let's create a noise top to serve as our base image. We need to do some basic settings for the noise top. First, press P to open its parameters, where you can see the adjustable noise properties. Click the monochrome toggle. This lets the noise output RGB color instead of a single-channel grayscale. Next, look at the period parameter. As you drag it, the noise pattern scales up and down. Set period to 0.7. Next, adjust the harmonics, the number of octaves. Set it to 1. The harmonics will decrease accordingly. Next, lower the harmonic gain value. Reducing it will make the noise edges softer, more blurred. Also reduce the offset value a bit. Lower offset pushes the noise toward black. 0.5 yields mid-gray, and 1 results in white. Increase the exponent to improve the transition between black and white. When working with noise here, think of it as an image, not as raw data to be processed numerically. Right-click the noise top's output and create a level top. Use level to tweak the color. Set the high green to 0.5 to reduce the green channel by 0.5. Now you can see the noise displays vibrant colors similar to those in my previous demo. Next, create a feedback top. The feedback top feeds back its previous output into its input each frame, letting you accumulate or evolve an image over time. Each frame, the feedback holds the last frame's image. By blending, transforming, or modifying that image before feeding it back, you get trails, motion blur, growing shapes, or iterative effects. I'll do a quick demo. Create a circle top and reduce its size. Adjust the radius parameter. When we move the circle, it currently leaves no trail because each frame replaces the previous one. With feedback, we can choose not to erase previous frames and instead preserve those past images. Okay, create a feedback top. Then place a composite top immediately after it to serve as the feedback's target. Remember to drag the composite top into the feedback top's target parameter. Set the composite top's operation mode to add. Then connect the circle top into the composite so it forms that feedback loop. Now, when we move the circle, you can see the trail it leaves. The feedback no longer erases each frame's image. Resetting the feedback will clear the accumulated trail. Then add a level top in the chain and set the opacity to 0.8. Move the circle again, and you'll see a fading trail instead of a solid one. Because the level multiplies each frame by 0.8 opacity, each successive frame gets multiplied by 0.8 again, so the trail gradually becomes more transparent. Okay, let's go back to the noise setup we were working on. Next, add a composite top after it and set the operation to maximum. Common composite modes used with feedback are add, over, and maximum. Create a null top after it. Move the viewer flag, the small blue dot, to the null to display it on the background for easier inspection. This is a common workflow. Now let's change the overall resolution to 1920 x 1080. Adjust the noise top's resolution parameter to 1920 by 1080. Then create a keyboard in Chop to reset the feedback. When you press the 1 key, it will reset the feedback. Click the small plus at the node's bottom right to activate it. Then drag the channel onto the feedback top's reset parameter, which is useful for observing and iterating on the image. Connect the level top into the composite, then drag the composite top into the feedback top's target parameter. Since we created a null, drag that null into the feedback top's target. This makes future edits more convenient. Now we need to insert a displace top in the chain. Displace simply offsets the image. Here we feed the feedback into the displace so the offset becomes iterative. The displacement keeps accumulating over time. Now, using the middle mouse button, create a standalone slope top. Here we use the slope top to turn the image into a sharper mask for emitting into the feedback loop. Enable the slope top, then right-click and choose Normalized. This makes the slope effect much easier to see. Set the slope top strength to 6.2 to increase its effect. Next, select the displace top and set its displace weight to 0.01. Then connect its output into the slope top. We can see there's no visible change. Select the noise top and change its pixel format to 32-bit RGBA. Then press the 1 key to reset. Now you should see a liquid-like displacement starting to form. Increase the displace weight to boost the displacement strength. Alright, now you can clearly see it moving, but the motion is a bit harsh. We'll refine and smooth it next. First, the edges are too hard. Add another displace in between to soften them. Then I also need to create a different noise top. Set its resolution to 1920x 1080 and its pixel format to 32-bit RGBA. Also enable monochrome, reduce the period value, and set harmonics to 0. This noise will serve as a coordinate map for the subsequent noise. Okay, create another noise top and enable monochrome. Connect that noise into the new noise top's coordinate map input. Adjust the resolution again. Next, connect it into the displace top. Set the displace weight to 0.001. Press 1 to reset again. Now it should look much more natural. We can also add a blur top to soften the edges and help them blend in. We can see the motion is just a diffusion-like spread. To add movement, put an expression on the noise top's transform Z parameter. For example, abs time.seconds. So the Z transform changes over time and adds dynamic motion. The speed is a bit fast. Multiply it by 0.02 to slow it down. We only need a subtle motion. Okay, I'll also try adding another displace to layer the effect. Add another displace top and set its displace weight to 0.01. I find the effect becomes overall too blurred if it runs for a long time, so I'll add a level top to change the feedback opacity to refine it. This principle was covered in the earlier demo. Now change the connections. Route the earlier slope into this chain first. Then create another slope top. Set its strength to 4 and connect that into the displace. I'll create a level, then add a null after it to use as the background. Adjust the level top to change overall saturation, contrast, and other image properties. Then use a composite top to layer the images together once more. Connect the previous null to the composite. Then set the composite's operation to add. Wow, this looks great now. Let's tweak the level top parameters. Feel free to experiment to find what looks best. I just adjusted them to values I think look good. Add an HSV adjust top to tweak the hue. Now we can happily tweak all the colors and parameters. You can spend a long time exploring and tweaking this. Now I need to add a star field effect. I want the upper half of the image to be as dark as possible. So I created a multiply top to multiply ramp. Create a ramp top and set it to vertical. Set the top color to black and the bottom color to white. Add a control point in the middle to adjust the boundary range between the top and bottom. Connect it to the composite set to multiply. Tweak the ramp as needed, and that part is done. I also want to tweak the colors a bit more, then connect the star field. Due to time constraints, I won't go through the full star creation process. I packaged it as a .tox and added it to the palette. You can download it from the link below and drag it into your project to use. It's made with the particle GPU component. You can adjust the particle size, birth, or life parameters inside it to get the effect you want. Connect it to the final composite and you'll get the sparkling star field. Thanks for watching. If this was helpful, please subscribe and like. Much appreciated.